But Liang Yin visited us from Sichuan University, and he liked the way Andy did things. Andy quickly taught him how to make these things. But Liang Yin said, well, look, I can really control things. I can align things really well. So let me make a slightly different structure. So rather than making this structure that did the co-flow, or the flow focusing of a co-flow, he made something that has two co-flow structures, but it collects here and runs them into here. So these drops are collecting here. So look, you have two drops here, and along comes a third. I've watched this movie many times. Along comes a third drop, and this breaks off now, and then everything starts again. And now you have really perfect control. So now you can make what I call designer emulsions. So now, you don't make just core shell structures. You want core shell structures. So, okay, well, how many drops do you want inside of them? And you tell me you want 5. I say, well, what size do you want? Not only can you control the number, but you can control the size very easily because each flow is perfectly well controlled. So Yang Yin showed me that. I said, well, that's very nice, but let's do something really different. And so look, here's an emulsion generator. Here's an emulsion generator. What about here? You can align them very easily, so let's just add a third emulsion generator. And that works perfectly. So now you make Russian doll emulsions. You make drops inside of drops inside of drops with really perfect control. Of course, you look at that and you say, who would ever do something like that except a stupid academic? Why would you care about this? So I told Liang Yin, we have to show you that you care about it. So we made a structure. This is a structure where this is an emulsion, a water and oil emulsion. It's all in an oil continuous emulsion, but this emulsion here has some very delicate peptides inside it. We want to protect it because outside in this emulsion there's a surfactants, all kinds of other things that you need in an emulsion. And so we want to protect them. So what we did was we used this ability to make these structures, and here we put a hydrogel. And that hydrogel protects this inner emulsion perfectly. But this particular hydrogel is thermoresponsive. It responds to temperature by shrinking, by trying to collapse. And so look what happens if we just gently heat it up. It tries to collapse, and it tries to squeeze the inside, but it can't. It's incompressible. So instead it tears itself apart and releases it. So what have I just showed you? I've showed you a structure that really encapsulates very well, but also that releases on command. And if you think about trying to make structures that encapsulate and release, your problem is never that you can't make something that very robustly encapsulates things. The problem is if you do, it's very hard to release. And it's also very easy to make something that releases easily, but it's very hard to make it robust in its encapsulation. By controlling all these fluids now, your imagination can run wild and you can make these structures that both robustly encapsulate and controllably release materials. And this is just an example. So